Good afternoon. This is me, Mr. Krishna Kumar Subedi, MAt Math Education 2024 batch student from Bhutan at Kathmandu University. So today I'm going to do my presentation on the topic logistic regression. So here, before going to this logistic regression, let us know what is regression analysis. uh, Here, regression is a statistical method that attempts to determine the strength and character of the relationship between a dependent variable and one or more independent variables. So basically it is about predicting a dependent variable with the help of a independent variable. So main types of regressions are linear regressions, logistic regression, and polynomial regressions. Then all the above regressions helps in analyzing and getting a particular value of dependent variable with respect to independent variable. So next, yes, so logistic regression first. So here, logistic regression is a predictive modeling technique when the dependent variable is categorical, meaning it can be nominal or ordinal data. So it calculates the log odds for a particular outcome. The odds of an outcome are given by the ratio of the probability of it happening or not happening. So logistic regression uses maximum likelihood estimation, which is called as MLE technique, to estimate the outcomes. Its odds are like P. P is the probability to and divided by total probability minus P, that is 1 minus P, where P is the probability of an event that is happening here. Then next is a statistical model used for binary classification like yes or no or 1 or 0 using threshold probability value is determined here. Means that with this help we can see what will be in our lower value below it and what will be at our upper value. So based on this we are going to see it is something like a discrete kind of result that we are going to get. Next is, so what is the difference between linear regression and logistic regression? So here linear regression is used for continuous dependent variables, whereas logistic regression is used for categorical dependent variables. So this is the main difference. Then outputs a continuous value. So output is a continuous value in case of linear regression, but in case of logistic regression, outputs are probability, a value between 0 and 1, which means it's a discrete. So either 0 or 1, we can say that. Then in case of linear regression, we use the linear function y is equal to mx plus b, and in case of logistic regression, we use a logistic function which is a sigmoid one, and that is given by f of x is equal to 1 over 1 plus e raised to minus x. So this function, when we plot, we'll get a sigmoid type of function or a graph. Then another difference is linear regression, it does not require a threshold value for prediction. So since it is a continuous graph, it does not require that. But it in case of logistic regression, it uses a threshold value, example 0.5, to classify based on the predicted probability. So it has particular let's say 0.5 is its probability value, threshold value. So based on that, whether it falls below or upward, it depends on that. So here we can see the two graphs. So first one is about linear regression, where we get a straight line, a line of best fit, and it can be also a continuous function. So in this graph we can say, for example, for 6.50 value, we can go up and again run towards the y-axis. We get certain value between 116 and 120. So this is in linear regression, directly we can get. So anywhere we can get the value. But in case of logistic regression, we see that this is a sigmoid curve, and it's fixed certain threshold is given here, that is 0.5 is its threshold value, and below this and above this we can find the value of probability of occurring of the dependent variable. So like y is equal to 0.8 for certain value on the x on the dependent variable, sorry, independent variable. Then likewise y is equal to 0.3 for certain independent variable. So this is how we can get it. So main difference we can see here is See, for logistic regression, we have 0 to 1 in the y-axis, that's a probability distribution, and threshold value is 0.5. Unlike this, in case of linear regression, we don't have this because it is a continuous graph. So this is the we have. Now, after knowing what is logistic regression and what are its graphs, let's see where we can apply the logistic regression. So application of logistic regression. Firstly, it is used in predictive analytics, that is to predict the probability of an event occurring, which is useful for forecasting like weather forecasting and all. Then fraud detection. Logistic regression models can identify anomalies in data that are predictive of fraudulent activity. Anomalies means here means something abnormal happenings. Logistic rejection model can identify anomalies in data, means if there is something unusual, all those things to detect, we can use this logistic regression. Then medical diagnosis, to diagnose diseases by assessing the presence or absence of specific conditions based on patient data. So whether it is present, that particular disease is present or not present, so we can define according to this logistic regression. Then customer churn prediction, which means identifying customers at risk of leaving a service or a company. Then statistics. Logistic regression can be used to sort data with a large ranges of values into smaller and finite range of values. So this is how we use in statistics. So these are some of the basic application of logistic regression. Uh, so this is all about my simple presentation on logistic regression, and to say that logistic regression can be done using SPSS as well as in R. So that part I'll be doing in next video. Thank you so much.